Welcome to a new chapter and a new part of our year. This is our first work about trigonometry, section 4-1, part 1, a different way to think about angles, or an introduction to trig. I've already been over this in class, so I'm going to go kind of quickly over this material. First of all, I want to start by reminding you that in the 10th grade, you all took a class called geometry. And in geometry, you dealt with angles quite a bit, all kinds of angles. And I'd like to remind you that in geometry, your angles took three distinct forms. There were angles like this one, two rays with a common endpoint. Let's say this is 42 degrees. That was called an acute angle. Then there were angles like this, again, two rays joined together, common endpoint. Let's say this one's about 118 degrees. These were called obtuse angles. And everybody knows and appreciates the right angle. We used it in many figures, equal to 90 degrees. This was called a right angle. All of these angles in geometry were composed of two rays joined together. They were freestanding, if you will. We use them in alternate interior situations, corresponding angles, all kinds of figures, rhombuses, rectangles, squares, octagons, hexagons, triangles. But they were all restricted to being somewhere between 0 and 180 degrees. In some text, I've even mentioned, not ours, but in some text, there is even this particular angle, this 180 degree angle, which is called a straight angle. We don't call that an angle, we actually call that a line. But put AKA, a line. But at any rate, this is all you get in geometry. This is pretty much it. These are your types of angles. Now what we want to do is we want to move beyond this. We want to think about angles in a different way as we move into trig. And so I'm going to try to quickly tell you about that difference. The two main differences as we move into trig are, number one, angles can have unlimited size, and two, angles can be positive or negative. And both of these are possible because of a change in definition. The first thing I'm going to do is I'm going to draw a little coordinate system right here. And I'm going to use a red, so hopefully you can see this a little better. I'm going to put a ray right here on the positive x-axis like that. And I'm going to put a dot here on the origin. Now imagine this ray is not one ray, but actually two. And one ray is going to stay there, and then I'm going to rotate the other ray like this so that I have opened up this angle. And let's just call it 64 degrees. Now this angle is in no way different from an angle that we might have had in geometry, except, as you can see, it's kind of superimposed over that quadrantal system. But instead of thinking about two rays that exist just out in the open, we're going to think a bit about this as a rotation. And this is actually a rotation of a ray from this point right here up into the first quadrant. So we've rotated this ray, kind of like a hands of a clock. This one is called the initial side right here. And this one right here is called the terminal side. Now, this is all well and fine, and so I'm going to draw several of these angles, and you're going to see that for the most part they look exactly like the ones we've been doing, such as if I kept this side here and I rotated this ray like this, and I call that 110 degrees. But now this is where our similarity ends, because in my third example right here, I'm just going to start right here on the terminal side. Remember, this is called standard position. And then I'm going to rotate all the way past the 180 mark. And I've actually gone past 180, and I'm going to call that 230 degrees. Now, this would not have been possible in geometry where we were limited to the 180 degrees. And in my fourth example, I'm going to show you how we can go around maybe even to here and call that a 300-degree angle. Again, starting here at the X, positive side of the X, and moving around. And then finally, in my fifth example, there's no reason that we could not go even more than once around. So once around is 360 plus back about 60 more. Let's call this 420 degrees. So we have an unlimited size of our angles because we can just spin around and around and around. We are no longer talking about just two rays that we put together, but rather we're talking about rotation, and this has numerous applications in the sciences. Now, not only can we talk about unlimited size in a positive rotation, but I'm going to slide this up so I won't waste this piece of paper. I'm going to draw a few more of these angles, and this time I'm going to start here on the positive, but I'm going to rotate this way. This is clockwise, and I'm going to call that angle negative 80 degrees. Let me draw several angles of negative size. Let's say this is negative 300 degrees. Notice you're going to have to show an arrow of rotation. And this one is negative 360, negative 720, plus a few more. We're going to call this angle negative 750 degrees. So these are our two main differences between angles of geometry versus angles of trig. These angles are unlimited in size and can also be positive or negative. Now let's get a clean piece of paper and talk to you a minute about another phrase. This is the phrase coterminal. Coterminal angles are angles that start and end at the same place. They have two roots, the word co, which means shared, and terminal, which means end. So these actually have a shared ending. Now let me just start with an example that I think is pretty simple. All right, let's start with an angle that we can identify with. Let's say 40 degrees. This is an angle 40 degrees, positive 40 degrees. Now I think it's clear to everybody that this angle started right here and it ended right here. And it went counterclockwise. Now, I want you to give me two angles, one positive and one negative, that start at this place where this one started and end at this place where this one stopped, but are not 40 degrees. Now, here's our general rule. If the angle itself is positive, which 40 is, then to find the negative is easy because we're just going to go back around the other side of the angle. In other words, we're going to complete the circle. And if this is 40, this is 360 minus 40, that's 320 in a negative direction. So negative 320 degrees would be a coterminal that is negative. It's easy, it's just the rest of the circle. Now the positive one is not so simple. We've got to start right here, end right here, but not be 40. So what we're going to do is we're going to have to run all the way around the block and come back to the 40. So it's 360 to go around, plus 40 makes your positive angle positive 360 plus 40, positive 400 degrees. Now again, you have to go start and stop at the same place. Let me do another positive example. Then I'm going to do a negative example. Actually, I'm watching my time here. I'm just going to do a negative one now. Let's say our example is a negative 140 degrees. This is our angle. And I want you to give me a positive and negative coterminal for negative 140 degrees. Let me push this up just a tad. Okay, now, since this angle is negative, it is easy to find the positive because we're just going to go from standard position. We're going to go around the other way. We're going to complete the circle. 360 minus 40 is 220. And so that is, a coterminal would be positive 220 degrees, the rest of the circle. Because this was negative, it's easy to find the positive. In our example before, the angle was positive, so it was easy to find the negative. Now to find another negative, you're going to start here. You're going to go all the way around, that's 360, and back to 140. So 360 plus 140 is 500. So our negative would be negative 500 degrees. All right, now, to me, the hardest example, and I'm going to do one more of these, and then I'll be out of time. The hardest example for coterminal is an angle that is already over 360 degrees. So let's take this one. Around once, around twice, that's 720 plus about 40 more. Let's say this is positive 760 degrees. Okay, now if I ask for coterminals for 760, since the angle is already above 360 degrees, you're going to have to figure out anyway, before you can draw it. You said around once 360, around twice 720. So you already know how much this angle is right here. That angle right there is 40 degrees. I had to know that just to be able to draw this. 720 plus 40 to get me to 760. So what I'm going to suggest is, since you already know that angle, I've colored it in with yellow here. I don't know if you can even see it, but there it is right there. That much is 40 degrees. Since you already know that, use that as your positive coterminal angle. And then for your negative, you just want to go the rest of the circle from 40, which is negative 320. Now we also need to remind you that there are lots and lots and lots of possibilities for these coterminal angles, infinitely many choices. In fact, we're going to try to keep our angles as small and compact as possible, and that's just a good rule to remember. Make it as simple as you can. All right, that's all for this first lesson on unlimited size of angles and positive and negatives and coterminals. Stay tuned to the next part of section 4.1, which you need to watch immediately after you finish this one. That's all for today. Thanks for listening. I'll see you tomorrow in class.